It uses a custom load cell that was machined from a single block of aluminum, and this load cell is positioned directly behind your motor. Hi, my name is Charles. I'm the president of Tyto Robotics. Today I would like to talk about a feature that is unique to our thrust stand, and that is the frictionless system. In propulsion testing, friction is the enemy of accurate measurement. The problems caused by frictions tends to snowball because the measurements are going to be used in your designs, and that can eventually lead to recalls or faulty products. Most manufacturers cannot afford to deal with this kind of issue. So where does the friction come from? In most simpler designs that use bearings or hinges, the issue is going to come from the friction that happens between the moving parts, even if the movements are microscopic. The error produced is going to range from anywhere between 2 and 20%, and you can't really account for this because the errors is highly nonlinear. On top of that, due to plastic deformation in the bearings, shocks, and also dirt and grime, the friction error is going to generally increase over time, which can cause worse measurement as the tool gets older. Again, it's very hard to account for this kind of inaccuracies. To avoid this problem, we have designed a solid-state system that gets rid completely of any bearing and hinge. It uses a custom load cell that was machined from a single block of aluminum, and this load cell is positioned directly behind your motor, close enough behind the motor that you don't need to have any kind of extension or pivots to transfer the force. No moving parts means no friction and highly accurate results. I encourage you to check out the flight stands datasheet, and if you have any question, don't hesitate to comment below or send us an email. Thank you very much.